Space elevators. Many consider this option as a fallacy or something from science fiction. The truth is that this alternative is closer than you imagine. Arthur C. Clarke wrote, "The space elevator is an idea whose time has come." You may now terminate your imaginative trip into space in a space elevator because in just 25 years, 2049, there well may be a space elevator that transports people and materials as far as the apex anchor, 100,000 kilometers, and then send them on to the moon and beyond. Space elevators are no longer just a figment of an author's imagination. To give a good example of why a space elevator is better versus traditional rockets, we can say that the Apollo example shows that only 0.5% of the pad mass at Cape Canaveral was delivered to the surface of the moon, with the rest consumed or thrown away. Yes, reusability improves costs and reliability, but it does not improve efficiency of logistics delivery. On the other hand, we can say that a space elevators will have a 70% delivery of the mass on the ocean at liftoff to the customer's destination, such as geosynchronous, geo, apex anchor, lunar orbit, Mars orbit, or anywhere else in the solar system, as illustrated in this example. Let's say the total weight of the space elevator plus the cargo equals 20 tons. Of which 6 tons correspond to the weight of the space elevator and 14 tons of cargo, in this case 6 tons of the Boeing X-37C rocket and 8 tons of containerized goods. To better illustrate what we are trying to explain, let's take the following example. Imagine the island of Manhattan, with all its population, its businesses, jobs, in short, everything that is done on this island day after day. Now just imagine that all the logistics, both of people, removing garbage from the island, logistics of goods and services, in general, everything that is done to maintain the pace of life on this island, is done through hundreds of ferries, since no bridge has been invented to date. It would be almost impossible to imagine, right now, what would happen if we built the first bridge, and not necessarily a big one. Imagine a bridge with only one lane going and another coming back. With this simple fact, the use of the ferry would be surpassed by far and forever. And this is because we are dealing with a fixed or permanent transport structure, which has many advantages over a ferry, such as that it does not pollute the environment. It allows the shipment of goods and services in both directions continuously and faster, in a safe, routine, efficient and economical way of all types of merchandise. It's basically the same comparison between any space rocket and a transport ferry, and a bridge with a space elevator. It's a permanent access structure to space. In a specialized factory, the tether with a length of 100,000 kilometers will be manufactured continuously. As the tether is rolled out, the coil will have a custom diameter and will occupy the total area of the external tank that was previously modified for this mission. The roll will be stacked on top of the first one without cutting it, roll after roll, until the 100,000 kilometers are stacked one on top of the other, continuously. Meanwhile, simultaneously with all of the above, a N.A.S.A. external tank, the same orange external tank used by the Space Shuttle, will be assembled. With the difference that it will be custom-made for this new purpose. This modification to the ET will consist of adding a cargo area on top of the external tank and booster rockets on its bottom. This will be possible because it will no longer have to carry the heavy space shuttle. Instead, it will carry the 100,000 kilometer long tether on top. Once the complete, continuous roll is packed inside the ET, its two booster rockets will be attached, which will help it take off from the platform and help it reach a low orbit. And then they will undock, and with its own engine, the ET will continue ascending until it reaches a geostationary orbit, GEO, over the equatorial Pacific Ocean. Once the external tank reaches GEO, it will hover in a position close to the trajectory between its Earth anchor and its apex anchor, and will remain there, in GEO, waiting for a while. Meanwhile, on the ground, two rockets from the Japanese space agency, JAXA, will take off to intercept the external tank at GEO. In this video, we will use J.A.X.A's H-2B rockets as an example. And two of their capsules will be specially modified for this mission. Upon reaching GEO near where the external tank is located, the two modified H-2B pods, hereafter referred to as stabilization satellites, will dock with the external tank and move it into position just above its ground anchor and turn the rockets to the top of. The rocket points directly towards its ground anchor, and the back of the rocket points directly at the apex anchor, at kilometer 100,000. Once the external tank is perfectly aligned, with its top facing the Pacific Ocean anchor and its back pointing toward the apex anchor, the stabilization satellite, pointing toward its Pacific Ocean anchor, will slowly and gently lift the tether out of the external tank's payload area. And the second stabilization satellite will tow the rocket toward the apex anchor. After several months, the stabilization satellite will slowly descend until it touches the surface of the sea, near its final anchorage in the ocean. In this case, an oil platform located on the equator in the Pacific Ocean. And simultaneously, the external tank must be located at its final point, perfectly in line with its opposite, the Earth anchor, in this case kilometer 100,000, to become the apex anchor. Climbers are the machines in charge of carrying and bringing the merchandise from the surface of the Earth to GEO and/or the apex anchor and back. Important note: the astronaut is 2 meters tall, and his purpose is to give an idea of the dimensions of the objects in this video. In this video we will assume that the tether has the following dimensions: a width of 1 meter, a length of 100,000 kilometers, and the thickness of a sheet of paper. In this video we will assume as an example that the company, Tesla, is in charge of manufacturing the climbers that will be used in this video, and they will be composed as follows. Tesla electric motors will be custom-made, and must be powerful, reliable, and able to withstand the harsh environment of space. Special tires that can withstand friction in the space environment. Both the motors and the special tires are configured in such a way that they press the tether from both sides precisely, so that it can go up and down. They are covered by an extremely resistant and at the same time light chassis that helps press the tires against the tether. It is made of a material that refracts sunlight and has built-in anchors where the containers that carry the merchandise are attached. Energy receiver. The energy receiver is shaped like a satellite dish and serves to receive energy in the form of microwaves or laser light that is sent from Earth. Electric pantograph. The electric pantograph is incorporated into the satellite dish and its function is to share energy with other climbers in case of a failure. The dimensions of the containers are as follows: 2.6 meters high, 2.43 meters wide and 1.7 meters deep, and the climber can load 10 of them. As previously mentioned, this example of a space elevator will be located on a huge platform in the equatorial zone of the Pacific Ocean. And the way the climbers will receive energy is by placing powerful satellite transmitters along the countries that are coastal to the Pacific Ocean. And from them lasers or microwaves will be emitted to power the climbers throughout their journey. It is estimated that on average, each space elevator system could hold about 10 climbers, of which the first 5 would always travel to the apex anchor, and the bottom 5 would reach GEO. This is due to the distance the climbers must travel. The distance from GEO to the apex anchor is almost double the distance from the Earth's surface to GEO. Simply put, for every 1 trip the first 5 climbers make from the Earth's surface to the apex anchor, the last 5 climbers make 2 trips from the Earth's surface to GEO. In this way, GEO could support projects such as multiple space solar farms, space sunshader, rotating space stations, back to the apex anchor, the most important section of this entire permanent space access structure. Its first function could be to become a humble gas station. From here the spacecraft could stock up on supplies and refuel as their last stop before embarking on interplanetary missions. The climbers could carry all the necessary fuel to the apex anchor and keep the oxygen and methane tanks full. Even the external tank cargo area could be filled with a custom-made inflatable capsule, shaped like the entire cargo area to house astronauts before departing on interplanetary missions. Let's take an example. For months, all the necessary parts to assemble the Lockheed Martin Mars base camp have been sent to the apex anchor. The astronauts can sleep in the habitat that was once the cargo bay of the external tank, and just a few days away from sending the mission to explore Mars. The Mars ascent, descent vehicle is sent, with the crew to the apex anchor to supply the ships with all the supplies, food, water and fill the ships with fuel to successfully carry out the mission on Mars. And at the perihelion of Earth and Mars, in just 61 days, this mission would be on Mars, since the release at the apex anchor allows speeds of 7.76 kilometers per second, making trips to Mars possible in reasonable times.